All right, students, welcome back to our Earth Space Science Day 8 of Unit 2. Mr. Campbell here to announce as well, if you haven't seen already, the Unit 2 quiz is now up and ready to be taken. Again, make sure you got your notebooks up to date, make sure you got your stuff up to date so that you can do your very best on that quiz and be fully prepared for it. It's 15 questions. Each question is going to be worth 2 points, so a total of 30 points. Again, our Unit 2 Quiz 1 has now been posted and is up and ready to be taken. As for other stuff, guys, again, I'm going to have a workbook assignment posted, which will probably do middle of next week. So that should be posted hopefully tonight, very soon. We've also got a new vocab, which I will show, which will be due the end of next week. So keeping things balanced as we go along per usual. But if we look up here, guys, you got our 2 Go Blue questions based off the things we learned from yesterday. And this is back over to page 10. We wrote a lot of these notes on pages 11 and 12, right? What would happen to the Earth if A, the magnetic field broke down, and B, magnetic poles reversed? And we're going to find this out through a video I want you guys to watch here in a moment. And then 2, what is the impact of Earth's convection currents, and what sphere are they found in? So again, what do the convection currents do for our planet, and are they in the lithosphere, the mesosphere, or asthenosphere? Go ahead and write these questions down on page 10 or 11 of your notebooks. You need to make sure, again, that you pause this video to answer them on your own and then analyze more from there. Okay, so for number 1, letter A, the magnetic field broke down. What happens? As we learned the other day, guys, if the magnetic field broke down, again, it is protecting the Earth. It is shielding the Earth from all of these dangerous solar rays, from all these dangerous radiation. Without that magnetic shield, guys, you've got evaporation of all water and all life on the Earth, okay? You've got the atmosphere completely breaking down. When you saw the video yesterday from the lesson, okay, Mars used to have a magnetic shield, right? Had some water, but that shield broke down from the solar wind and the solar flares. You guys can see kind of a bit here. And what happened to Mars? Mars is a lifeless, rocky planet, whereas the Earth has a very strong shield that's created, again, by its iron core, right? And that shield protects us. And it allows us to have our water, our atmosphere, so on and so forth. So I want you guys to actually watch this video here. This is going to answer our question for letter B. Again, just put down for the Go Blue, dangers of the magnetic field flipping, which is already in our Go Blue. So I'm going to post this video, or show this right now, just a little bit of it, and you're going to have to watch the rest of it on your own. Let's check it out.
Evidence suggests that for hundreds to thousands of years at a time, our planet has had 4, 6, and even 8 poles at a time. This is what has happened when the magnetic poles flipped in the past. And when it happens again, it won't be good news for humans. Now you might think that 8 poles must be better than 2, but the reality is that multiple magnetic fields would fight each other. This could weaken Earth's protective magnetic field by up to 90%.
So first point, it would weaken it, right?
During a polar flip. Earth's magnetic field is what shields us from harmful space radiation, which can damage cells, cause cancer, and fry electronic circuits and electrical grids. With a weaker field in place,
So there's a multitude of them. And again, I want you to watch all this on your own so you get the full length actual effect that it has on our society. But some of the ones I wanted you guys to highlight are included here, okay? We've got weakened magnetic shield. Big problem. It's not going to be diminished. It's not going to evaporate our planet, right? But it's going to make it weaker, and that's bad because what does that do? That means increased skin cancer, increased cancer from all the radiation. Damage to electronics. Maybe all the phones go out, all the satellites go out, all the power grids go out. Big problems, guys. We're so used to our electronics, right? Plane navigation. Radars don't work. We can't fly to and from cities for a long period of time until that gets fixed, right? And then animal migration. Animals depend on the magnetic shield to migrate. You have your birds, you have monarch butterflies, you have fish, turtles. That affects a lot of them as well, okay? Going back to number 2, what do the convection currents do for our planet? Where are they found? The currents heat the Earth and move tectonic plates. So they're the conveyor belt. They're the reason why the continents move, the reason why they separate. Again, it's those currents happening in the mantle of the Earth, the middle mantle, right? But what sphere are they found in is the real question. The sphere they're found in is the mesosphere or the asthenosphere. They're kind of in both. They're going to impact the plates at the asthenosphere, but they're flowing throughout the mesosphere. So I'm just going to say both. If it is a test question, I'll just mark them both as correct, I think, because I just feel like it's both. All right. All right. That concludes Go Blue for today, guys. You need to have that on page 10 or page 11 if you need more room. Moving on. We just did that video, right? Again, I think the table of contents is the same as it was yesterday on page 1, so update that if you did not already, because you never know. A table of contents page could be a notebook check page, right? Got another notebook check coming up here probably next Friday. Earth's magnetic field and heat, guys. Earth's magnetic field and heat, we had that. Okay, let's go ahead and take a look at where we left off. And actually we're going to start the day with a question. Really quick, guys, I need you to write down this term here as slab pole. I just pressed a button. Okay. Slab pole. This is a super important term. I'm going to show you a video of this in a second as well. Okay. So slab pole, this needs to be on page 10, page 9, wherever you got an opening, right? Okay. So page 9 or 10. Parts of cold, dense tectonic plates get pulled into the Earth's mantle through subduction. These form trenches. What are we talking about here, okay? So the tectonic plates aren't just bumping into each other. They're not just sitting side by side. Parts of the plates are actually going beneath another plate, and kind of like, in a sense, it's eaten. We call that subduction. It goes beneath. You guys can see this here, right, in all these GIFs. It's going to go beneath, and that plate is going to melt in the hot mantle. It's going to melt in the hot mantle. And when it does that, it's our planet's way of recycling crust, okay? So on one end, we're going to call this slab pole. The slab gets pulled down into the mantle and gets melted and recycled. And when it gets pulled down, guys, it makes a divot in the ocean floor. This divot are the deepest parts of the ocean. Again, we call those trenches. We're going to find out tomorrow what happens on the other side of that. So let's go ahead. I got a video here that I'm going to attach to our post later today, okay? Let's get a visual for that slab pole.
It happens because hot rock rises, heated by the Earth's core.
And we can see here what's flowing in there in the mantle. It's the convection currents, right? Those are the wheels. Those are what's moving those plates around.
Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move.
Okay, so I'm going to have you guys watch the rest of that on your own. Again, that's on you guys to do all this. You get the full, because if I show all the videos from YouTube, again, they can mark me for it and get on me about it. So I got to make sure I only show little samples of the videos that you guys need to watch on your own. But let's continue, guys, with a practice question. We talked about slab pole. We've got that. I know you guys love French fries. We've had a big debate on campus, and I have a vote on the French fries. I have people say, okay, what's the best French fries? The majority of students have been saying that Chick-fil-A is the best. I've got to show McDonald's some love here. I got McDonald's up here, and McDonald's was always second. Chick-fil-A was first. I think some other ones that were mentioned were like Checkers, and we had Wendy's too. So whatever French fries you guys like, again, maybe I'm thinking they're probably within the same ideas there. So French fries are being heated under a lamp. This is an example of what type of heat transfer, right? So the lamp is heating up the French fries after they've been fried, right? A, magnetism. B, radiation. C, conduction. D, convection. Please go ahead and pause this video. Think about this question. Answer it on your own, and then play the video once you're ready to see the answer. Okay. Let's go ahead and see what we got. Answer is going to be B, radiation, guys. Again, radiation. You got the waves. You got the heat from the waves of the lamp affecting the French fries, keeping them hot for the customers, right? Okay, really quick on page 10, just write other magnetic fields. You don't need to write all the stuff, all the words in white and or red. You don't need to write all that, no worries, okay? But what we're going to look here is I've got Earth and I've got Venus, okay? Two planets, very similar in their makeup, composition. They had the same core, okay, iron core. They got a lot of this similar size. Venus is the second planet from the sun. The Earth is the third planet from the sun. So why is it that both these planets are so different? How is it that Venus no longer has a magnetic field? Which of these factors, these 6 factors in your mind and in your opinion, which of these are going to determine why you think that the magnetic shield isn't happening on Venus? There's one big reason. It has to do with what we see here. Take a moment, pause, think about it. Pick which one. Of these 6, between revolution, rotation, moons, radius, mass, atmosphere, it's one of them. Take a moment to think about it. Pause the video. Okay. Getting back to it, guys, the answer is going to be rotation. Okay. A day on Venus lasts for 243 days on Earth. Okay. It rotates too slow. So good. Venus rotation is too slow to create a magnetic shield. Okay, that is your answer. Only write what's in yellow, just the title and the sentence there. Venus does not have a shield because it rotates too slow. In fact, it rotates backwards. And they think it's because an asteroid hit it. Pretty interesting stuff. And I'm going to show the Venus video tomorrow. That's pretty cool. But again, Venus rotation is way too slow. It's why, and it goes backwards. It's why it doesn't generate, kind of like a hamster wheel producing power, but why it doesn't generate power, right? I'll show that video tomorrow. So the last thing I want you guys to write today is this section here, Earth's magnetic field. I'm going to highlight that before again, the 7th period is about to start for me. Again, what generates Earth's magnetic field? We've got the iron inner core. That iron inner core really produces that shock, produces that shield very strongly. It's also another big thing, guys. Again, write everything that's yellow. This is all important stuff. Is the rapid rotation. Earth, compared to a lot of planets, is spinning, rotating pretty fast. I mean, 24 hours is not a long time for it to spin once. So that's going to be generating that shield and producing life on Earth as well. Pretty awesome stuff. If you think about it, no matter how you look at it, guys, Earth is a miracle. Like, I mean, there are just so many factors at play that make life on Earth, that make the clouds, the atmosphere. I mean, it's really a beautiful miracle. It really is, okay? And also, guys, keep to note, Earth's magnetic field periodically reverses, right? So again, that's going to be a problem. We talk about why that's an issue when it flips, right? Okay, so pause this video, write this down on page 10 or 11, because we have to move on. Our last question of the day, guys, which helps conduct Earth's magnetic field the most? We just talked about it, right? A, convection currents, B, core rotation, C, nickel, or D, iron. Again, which has the strongest effect on Earth's magnetic field? Think about it, pause this video. The answer is going to be D, iron, guys. The iron inner core, kind of like the copper in a wire, with that current of electricity flowing through it, okay? This is going to produce that magnetic energy throughout the planet. So the iron inner core, okay? We already did this question. We're already good on that. We'll talk about technology tomorrow. We'll do more questions tomorrow, guys. That concludes our lesson today. Again, get that quiz done. Make sure you guys get the I'll have a new vocab up that's due next Friday, and I'll have workbook pages due as well. But get your notes up to date, guys. Get all your other missing assignments done. The quarter ends in 2 weeks. We got to make sure we do our makeup work. Don't fall behind. Take your attendance quizzes. Message me on Canvas. I'm going to be calling, I think, just my e-learning parents just to check in, make sure they know, hey, we've just got, 2 weeks left. We got to make sure we get all of our work turned in, get everything taken care of. This is Mr. Campbell signing out. I will see you guys tomorrow with lesson, I believe, 8 or 9. Take care, Mr. Campbell signing out. Message me, contact me on Google Voice or Canvas Messenger to get all the full updates if you have any questions.